Hi all, welcome to Heights to Fly. Today we are discussing about composition of functions. In previous class we discussed about relations, functions, types of relations and functions. Today we are discussing about composition of functions. What is composition of functions? Consider two functions given by let f be a function defined from A to B and g is another function defined from B to C. The composition of f and g, which is represented by g composition f, the composition of f and g represented as g composition f. G composition of f of x is equal to g of f of x. G of f of x, which is a function defined from A to C. It is a function defined from A to C for all x element of A. For all x element of A. Once again, let f be a function defined from A to B and g be a function defined from B to C. Then we can represent a f composition g as this symbol. G composition f of x is equal to g of f of x, which is defined as a function from A to C. Okay, let's discuss it through an example. Consider let f be a function defined from set 1, 3, 4 to 1, 2, 5 and g is another function defined from 1, 2, 5 to 1, 3, then given by f is equal to set 1, 2, 3, 5 and 4, 1 and g is equal to 1, 3, 2, 3, 5, 1. And we have to find what is g composition f. What is g composition f? Let's go to the answer. What is f is equal to the sets. F is a function sets 1, 2, 3, 5 and 4, 1. G is equal to set 1, 3, 2, 3 and 5, 1. Then G composition f of first element of G is 1 is equal to G of f of 1, which is equal to f of 1 in function f. One's image is 2 f, so f of 1 is equal to 2 g of 2. Then in function g, image of 2 is 3. Image of 2 is 3. Another decomposition f of 3, that is g of f of 3, and f of 3 is equal to 5, so g of 5 is equal to 1. Another one, decomposition f of 4 is equal to g of f of 4, which is equal to f of 4 is equal to 1, so g of 1 which is equal to g of 1 which is equal to 3. Okay, so we can write the set g of f of x is equal to set 1 3 3 1 1 3 1 1 3 3 1 4 3 1 3 3 1 4 3. For the value 1, the image is after decomposition of the value is 3, 4 3 it is 1, and 4 4 it is 3. Hope you understand. And once again, it is a function defined from A to C. We are taking values 1 3 4 1 3 4, corresponding images of f of 1 is equal to 2, then g of 2 which is equal to 3. Okay, let's go to another example. Question is, find decomposition f and f composition g. F of x is equal to cos x and g of x is equal to 3x square, and also show that g composition f not equal to f composition g. Here f are defined from real numbers to real numbers, g also defined from real numbers to real numbers. G composition f and f composition g, where the function f of x is equal to cos x, g of x is equal to 3x square, and also have to show g composition f not equal to f composition g. Let's find first g composition f, which is equal to g of f of x. F of x is equal to cos x, so g of cos x, that is g of x is equal to 3x square. G of x is equal to 3x square. So here the value of x is cos x, so here 3x square. Here the value of x is cos x, so we have to substitute the value of x here, that is 3 cos square x. 3 cos square x. Okay, f composition g is equal to f of g of x, which is equal to g of f of g of x is equal to 3x square. Here the value of x is equal to 3x square. Value of x is equal to 3x square. F of x is equal to cos x. Okay, we have to substitute the value of x with the 3x square, so cos 3x square. This is the answer. Once again, g of cos x, the value of x is cos x, so we are substituting the value of x with the cos x, so 3 cos square x. Here the value of x is equal to 3x square, and here it is cos x, so substitute x with 3x square, so cos 3x square. Therefore we can say that g of x not equal to g composition f not equal to f composition g. G composition f not equal to f composition g. Next question. The question is somewhat lengthy. Show that if function f defined from real numbers minus 7 divided by 5 and numbers minus 3 divided by 5, the function is f is defined like this, and is defined by function f of x is equal to 3x plus 4 divided by 5x minus 7, and g is also defined from this set to this set and is defined by 7x plus 4 divided by 5x minus 3. Then we have to find f composition g and g composition f, which is equal to identity functions of A and identity functions of B, where A and B are defined as A equal to R minus 3 divided by 5 is equal to R minus 3 divided by 5 and B is equal to R minus 7 divided by 5. Okay, let's go to the solution. Let's go to the solution. First we have to find decomposition f of x, that is g of f of x, where the f of x is equal to 3x plus 4 divided by 5x minus 7. Okay, f of x is equal to 3x plus 4 divided by 5x minus 7. What is g of x? 7x plus 4 divided by 5x minus 3. So the value becomes, that is we have to substitute this value for x, for each x, that is 7 into 3x plus 4 divided by 5 minus 7. Then again here 5 into 3x plus 4 divided by 5x minus 7. Okay, then simplification, here plus 4 and here plus 4 and minus 3. So plus 4 minus 3, you have to simplify it by finding LCM. Here the LCM is 5 minus 7 and here also 5 minus 7, so they get cancelled. Okay, we can write 5x minus 7, then 7 into 3x plus 4 plus cross multiplication, here the LCM goes to here, and 20x minus 28, the whole divided by, here also the same process, 5 into 3x plus 4 minus plus 15 minus 15x plus 21. Okay, the whole divided by 5x minus 7 is gets cancelled. Then we have to open the bracket, 21x plus 28 plus 20x minus 28 divided by 15x plus 20 minus 15x plus 21. After addition and subtraction, 21x, 20x, 41x, 28x minus 28 minus 28, 0. Then it gets cancelled, plus 40 plus 20 plus 21, 41, which is equal to x. Okay, then if composition g of x is equal to, same, f of g of x is equal to 7x plus 3 divided by 5x minus 3. 7x plus 3 divided by 5x minus 3. Again the substitution in f, that is 3 into, here the function f is equal to 3x plus 4 divided by 5x minus 7. 3 into 7x plus 3 divided by 5x minus 3 plus 4 divided by 5 into 7x plus 3 divided by 5x minus 3 minus 7. Okay, here the LCM values are 5x minus 3, 5x minus 3. In the previous case, we discussed this in previous case. Similarly, it get cancelled. Then 21x plus 9 plus 9, 21x. Here the value is 12. Okay, here the value is, so it is 12 plus 7x plus 4, question 7x plus 4, 5x minus 3, that is 15, 20x minus 12 divided by 35x plus 50, 7x plus 4, 7x plus 4, 20 plus minus 35x plus 21 is equal to 41x. This get cancelled, divide by 41, which is equal to x. Here decomposition f and f composition g is equal to x. Decomposition f of x is equal to x for every x element of B. And similarly, f composition g of x is equal to x for all x element of A. It implies that decomposition f is equal to IB and f composition g is equal to IA. F composition g is equal to IA. Here we got the values x and x, so we write it as for every element of x is equal to x element of B, for every element of x element of B. Because we take such values, f composition is equal to x for all x element of A, so we can write it as IB and we can write it as IA. Identity functions. Next question. If f is function a to b and g b to c, we have to show this is 1 to 1 and the functions are 1 to 1, then decomposition f a tends to this function is also 1 to 1. Okay, question is show that if the function f is defined from a to b and g is defined from b to c, are 1 to 1. What is 1 to 1? Every x takes a single image, is have distinct image. Such functions are called 1 to 1 functions. Functions. Also 1 to 1 and onto. Okay, what is an onto function? Range is equal to all elements participate in the range. All elements participate in range. In previous class we discussed this thoroughly. Okay. Consider, suppose decomposition f of x1 is equal to decomposing, we are starting from this statement, then g of f of x1 is equal to g of f of x2, f of x1 equal to f of x2. If this have to prove, this should be equal, then we can say that x1 is equal to x2 because f is 1 to 1. F is 1 to 1. So we can say that if f is so we can firstly say decomposition f is 1 to 1. We take decomposition f of x1 is equal to decomposition f of x2. We get to the statement x1 is equal to x2. This is true because f is 1 to 1. In the question itself it is saying that f is a function which is 1 to 1. So we can say that decomposition f is also 1 to 1. And let's go to the onto statement. Consider an element Z, which is an element of C, set of C. Consider an element Z which is an element of set C. Then we can say that g of y is equal to Z. Okay, g of y is equal to Z because the function g is b to c. Then we are taking an element g of y from b, g of y is equal to Z. So f of x is equal to y. the reverse processing. F of x is equal to y, so g of y is equal to z. Then decomposition, f of x is equal to g of f of x, which is equal to g of y, which is equal to z. From this statement we can say that decomposition f is onto, that is each element of c participating in this function. Each element of c is participating in this function, so decomposition f is onto, decomposition f is 1 to 1. Next question. Next question is find decomposition f and f composition g if f of x is equal to mod x and g of x is equal to mod 5x minus 2. So again, f of x is equal to mod x and g of x is equal to mod 5x minus 2. And the second question, f of x is equal to 8x raised to 3 and g of x is equal to x raised to 1 by 3. Okay, let's go to the first question. Here the f of x is equal to mod x and g of x is equal to mod 5x minus 2. Then the composition f of x is equal to g of f of x, and g of f of x is equal to mod x, value of x we have to take the value of mod of x. Here the x value is mod x, so we have to substitute this mod value here, 5 mod x minus 2. Once again, here the x value is taking mod x. What is g of x? 5x minus 2. So we have to substitute this mod x in this x. So 5 mod x minus 2. Next, 5 composition g of x, which is equal to f of g of x, which is equal to f of g of x is equal to mod 5x minus 2. Mod 5x minus 2. Here the value is mod x. Here the x is 5x minus 2. So we have to substitute x with this x value, that is mod 5x minus 2. Mod of mod is equal to mod 5x minus 2. Mod 5x minus 2. For the second question, f of x is equal to 8x raised to 3 and g of x is equal to x raised to 1 by 3. F of x is equal to 8x raised to 3 and g of x is equal to x raised to 1 by 3. Okay, decomposition f of x is equal to g of f of x. Here the value of f of x is equal to x raised to 3, g of 8x raised to 3. Then the value of x is 8x raised to 3 and we have to substitute this value of x here. So 8x raised to 3 the whole raised to 1 by 3. The value of x is 8x raised to 3. So substitute this in this place. So x raised to 3 divide the whole raised to 1 by 3. That is the cubic root of this value, which is equal to 2x. Cubic root of 8 is equal to 2 and cubic root of x raised to 3 is equal to x. And the second case, f composition g of x, it is equal to f of g of x. Then g of x is equal to x raised to 1 by 3. That is the value of x is x raised to 1 by 3. So we have to substitute this x raised to 1 by 3 here. Okay, then 8. Here the x value is x raised to 1 by 3. So x raised to 1 by 3 the whole raised to 3 which is equal to 8 as a raised to m in the whole raised to n, a raised to m into n. So 1 by 3 into 3 cut 8x. Okay, once again, here the value of x is x raised to 1 by 3. We have to substitute this here. So x raised to 1 by 3. So we have to substitute the x value with the x raised to 1 by 3. We can write this. So today we discussed what is composition of functions and what are the different kinds of problems that we have to be discussed in composition of composition of functions. Our next class we will discuss more about composition of functions and invertible functions. So thank you for watching. Subscribe and share for new videos.